Picture this. You step outside one night and look up at the sky, but something feels wrong. The familiar bright circle that has guided humanity for thousands of years is gone. No more moonlight dancing on water, no more romantic walks under its glow, no more werewolf movies. The moon has vanished. But here's the terrifying part. Losing our celestial companion wouldn't just ruin poetry and date nights. It would fundamentally break our planet in ways that would make the worst disaster movies look like children's bedtime stories. Today we're diving into one of the most mind-bending questions in astronomy. When will the moon actually disappear? And what catastrophic changes would unfold on Earth without it? I'm talking about massive tsunamis, climate chaos, and the potential collapse of life as we know it. But before you start panicking and booking a one-way ticket to Mars, let me tell you something that might surprise you, sis. The moon is already leaving us, just incredibly slowly. Every single night as you sleep peacefully in your bed, our moon drifts approximately 1.5 inches further away from Earth. That's about the same rate your fingernails grow. It doesn't sound like much, but over cosmic timescales, this tiny drift adds up to something absolutely massive. The moon has been our loyal companion for about 4.5 billion years, but this relationship isn't permanent. Nothing in the universe truly is. So when exactly will our moon bid us farewell? The answer involves some pretty wild physics and timescales that will make your head spin. Scientists calculate that the moon will continue its slow escape for approximately 50 billion years before it finally breaks free from Earth's gravitational embrace. To put that in perspective, our sun will have already expanded into a red giant and consumed our planet in about 5 billion years. So technically, Earth will be long gone before the moon says goodbye. But what if we ignore that inconvenient solar death and focus purely on the moon's departure timeline? The process isn't linear either. For the next several billion years, the moon will gradually drift further away, making Earth's days longer and longer. Right now, a day lasts 24 hours, but when dinosaurs roamed the Earth, days were only about 22 hours long because the moon was closer and Earth spun faster. As our satellite continues its cosmic journey outward, days will eventually stretch to about 25 hours, then 26, and keep growing until each day lasts about 47 of our current days. Imagine trying to maintain a sleep schedule in that world. But here's where things get really interesting and slightly terrifying. Long before the moon completely escapes Earth's gravity, its influence on our planet will become so weak that we'll essentially be living in a moonless world anyway. This will happen much sooner than 50 billion years, probably in just 15 to 20 billion years, when the moon has drifted so far away that its effects on Earth become negligible. Now let's explore what would actually happen to our planet without its faithful companion, because the consequences are far more dramatic than most people realize. The moon isn't just a pretty nightlight hanging in our sky, it's literally one of the most important factors keeping Earth habitable for complex life. First, let's talk about tides, because most people think that's all the moon does. Without our lunar companion, ocean tides would virtually disappear. Instead of the dramatic high and low tides we see today, driven primarily by the moon's gravitational pull, we'd only have tiny solar tides caused by the sun. These would be roughly 1/3 the strength of current tides. This might sound like a minor inconvenience, but tidal forces have been absolutely crucial for the development and maintenance of life on Earth. Tides create unique ecosystems in coastal areas, mixing nutrients and oxygen throughout the water. They've also been essential for the evolution of life itself. Many scientists believe that tidal pools created by lunar forces provided the perfect laboratory conditions for early life forms to develop and eventually make the transition from ocean to land. Without strong tides, this evolutionary pathway might never have existed. But the disappearance of tides would be just the beginning of Earth's problems. The moon plays a massive role in stabilizing our planet's axial tilt, and this is where things get truly catastrophic. Earth currently tilts at about 23.5 degrees relative to its orbital plane around the Sun. This stable tilt gives us our regular seasons, summer, fall, winter, and spring cycling, predictably year after year. Without the Moon's gravitational influence acting as a cosmic stabilizer, Earth's axial tilt would become chaotic and unpredictable. Computer simulations show that our planet's tilt could vary wildly between 0 and 60 degrees or even more. Imagine the North Pole sometimes pointing directly at the Sun, creating a scenario where the Arctic becomes a scorching desert while the equator freezes into an ice sheet. These dramatic tilting episodes wouldn't happen gradually over thousands of years. They could occur within just a few thousand years, which is basically instantaneous in geological terms. The climate consequences of this unstable tilt would be absolutely devastating. We could experience ice ages that last for millions of years, followed by periods of extreme heat that would make current global warming look like a minor temperature adjustment. The predictable weather patterns that agriculture depends on would become completely unreliable. Growing food would become nearly impossible, as farmers would never know whether the next season would bring Arctic temperatures or desert heat. Ocean currents, which currently help regulate global temperatures by moving warm water from the equator toward the poles and cold water in the opposite direction, would also become chaotic. These currents are partially driven by the Coriolis effect, which is influenced by Earth's rotation and tilt. With wildly varying axial positions, ocean circulation patterns would constantly shift, creating even more climate instability. But wait, there's more. The Moon also affects the length of Earth's days through a phenomenon called tidal friction. As I mentioned earlier, our days are gradually getting longer, but this process is actually helping to stabilize Earth's rotation. Without the Moon's influence, Earth would spin much faster. Days would likely be only 6 to 12 hours long. This might sound exciting, like getting more done in a day, but it would actually create incredibly violent weather patterns. Faster rotation means stronger Coriolis forces, which would generate much more powerful storms and hurricanes. We're talking about wind speeds that could regularly exceed 200 miles per hour. The faster spin would also create more extreme differences between day and night temperatures, as there would be less time for heat to distribute evenly around the planet. The magnetic field effects are another concern that scientists are still studying. Earth's magnetic field, which protects us from deadly solar radiation, is generated by the movement of molten metal in our planet's core. Some researchers suggest that the Moon's gravitational influence might help maintain the complex fluid dynamics in the core that generate this protective magnetic shield. Without the Moon, our magnetic field might become weaker or more unstable, leaving Earth more vulnerable to harmful radiation from space. Let's talk about what this would mean for life on Earth. The combined effects of chaotic climate, extreme weather, unstable temperatures, and potentially reduced magnetic protection would create an environment where complex life would struggle to survive. Many species that have evolved over millions of years in Earth's current stable conditions would likely go extinct. Humans would face unprecedented challenges. Agriculture would become nearly impossible without predictable seasons. Coastal cities would need to completely restructure without regular tides. The rapid day-night cycle would disrupt sleep patterns and biological rhythms that have evolved over millions of years. Even if we could technologically adapt to these changes, the social and economic disruptions would be enormous. Marine ecosystems would be among the hardest hit. Many ocean species depend on tidal cycles for feeding, breeding, and navigation. Without the Moon's influence, these ecosystems would collapse, potentially triggering a cascade of extinctions throughout the ocean food chain. Coral reefs, already vulnerable to climate change, would face additional stress from the lack of tidal water movement that helps bring nutrients and remove waste products. Bird migration patterns would also be severely disrupted. Many species navigate using the Moon as a celestial compass, and the chaotic axial tilt would make star navigation unreliable as well. This could lead to massive die-offs of migratory species and further ecosystem collapse. Interestingly, some effects of losing the Moon might not be entirely negative, at least in the short term. Without tidal friction gradually slowing Earth's rotation, our planet might maintain its faster spin for longer periods. This could potentially generate stronger magnetic fields in some scenarios, offering better protection from cosmic radiation. The lack of tidal heating in Earth's crust might also reduce geological activity in some regions, potentially decreasing earthquake and volcanic activity. However, these potential benefits would be vastly outweighed by the negative consequences. The geological stability that comes from tidal forces also helps drive plate tectonics, which play a crucial role in regulating Earth's carbon cycle and maintaining long-term climate stability. Without this influence, our planet's ability to regulate greenhouse gases through geological processes could be compromised. From a human perspective, losing the Moon would also have profound cultural and psychological impacts. The Moon has been central to human culture, religion, and timekeeping for thousands of years. Lunar calendars have guided agricultural activities and religious observances across virtually every civilization. The loss of this celestial timekeeper would require fundamental changes to how we organize society and understand our place in the cosmos. The good news, if you can call it that, is that we have an incredibly long time before any of this becomes a real concern. As I mentioned earlier, the Moon's departure timeline spans tens of billions of years, far longer than complex life has existed on Earth, and far longer than our Sun will continue to shine. By the time the Moon drifts far enough away to cause these problems, humanity will either have evolved into something completely different, developed technologies we can't currently imagine, or found new homes among the stars. In fact, the gradual nature of the Moon's departure might actually give life on Earth time to adapt. Evolution has already shown remarkable resilience in the face of major environmental changes. Species that can tolerate wider temperature ranges, more variable weather patterns, and different day-night cycles might gradually become more common. Life might find ways to thrive, even in a moonless world, though it would likely be very different from the life we know today. Scientists are also exploring whether advanced civilizations might be able to prevent or reverse the Moon's departure using currently unimaginable technologies. Concepts like massive space-based gravitational manipulators or even moving the entire Earth-Moon system to maintain their relationship are purely theoretical, but they represent the kind of cosmic engineering that sufficiently advanced species might attempt. The study of what Earth would be like without the Moon also provides valuable insights for astrobiology, the search for life on other planets. Most planets in our solar system don't have large moons like ours, yet some of them might still harbor life in subsurface oceans or other environments. Understanding how the Moon contributes to Earth's habitability helps scientists better evaluate the potential for life on exoplanets and moons throughout the galaxy. So while the prospect of losing our Moon might sound terrifying, it's ultimately a reminder of how precious and unique our current situation really is. Earth and the Moon formed through an incredibly unlikely cosmic accident. Most theories suggest that a Mars-sized planet called Theia collided with early Earth, and the debris from this collision eventually coalesced into our Moon. The chances of this happening were astronomically small, making our Earth-Moon system something truly special in the universe. Rather than worrying about events that won't occur for billions of years, perhaps we should focus on appreciating what we have right now. The next time you see the Moon hanging in the night sky, take a moment to consider all the ways it's quietly working to keep our planet stable and habitable. From the tides that shape our coastlines to the stable seasons that make agriculture possible, our celestial companion is constantly working behind the scenes to maintain the delicate balance that allows life to flourish on Earth. The Moon will eventually leave us, but its departure timeline is so vast that it makes human civilization look like a brief flicker in cosmic history. We have countless generations ahead of us to enjoy moonlit nights, watch tidal movements, and benefit from the stabilizing influence our satellite provides. And who knows? By the time the Moon finally says goodbye, perhaps we'll have become the kind of advanced civilization that can either prevent its departure or thrive without it among the stars.